Hello everyone, I'm Daniel at QNAP and I'm here to talk about how to select the right NAS for your use case and also how to select the right configuration for your use case. And this is important because one NAS is not going to fit all use cases and one configuration is not going to fit all use cases. For example, we have NAS that are excellent for video editing or like a file server, and some of those same NAS may not be excellent for Plex. And there's plenty of other examples like that where one NAS will be excellent at one thing and not so great at another thing. And so it's worth putting some thought into what's the right hardware and what's the right configuration for your use case, because that way you can get much better performance for your money. So let's get into this. So for our agenda today, we'll talk about challenges in choosing the right NAS and right configuration for your use case. We'll go over some technical terms that will come up often, and it's important to understand these terms to really know how to make a good decision for your NAS and configuration. Then we'll talk about what's important for each use case, and that's because different use cases have different needs. And so what performance factors are most important, or just what factors are most important for what you're trying to do with your NAS. And then we'll go over various different use cases, and then for each use case, we'll go over specification, configuration, and recommended models. So first of all, challenges. One of the major challenges is that one NAS is not going to fit all use cases. So for example, like a TS1685 is excellent for video editing, lots of capacity, lots of throughput. It's not excellent as a Plex media server. For example, even though it's a great powerful unit, its transcoding ability is less, for example, than like a TVS 472XT. So choosing the right NAS can be difficult because different NAS are really good at different things and may not be so good at other things. And so this is really worth putting a lot of thought into because you can save yourself a lot of money by really spending your money where it helps you the most for what you are doing. So for some technical terms I want to go into first, let's talk about throughput versus IOPS. We'll talk about transcoding, RAID, HDDs versus SSDs, and our caching feature versus our Q-tier feature. So first of all, throughput versus IOPS. These are both involving performance, but they're different. Throughput is measured typically in megabytes per second. It's how many megabytes per second can you read from the NAS, or how many megabytes per second can you write to the NAS. And throughput really matters when you are dealing with medium to large files. On the other hand, there's IOPS. And IOPS is not measured in megabytes per second. IOPS is measured in operations per second. And IOPS can really matter a lot when you're dealing with small file transfers, or random reads and random writes. Really small files tend to be more random reads and random writes, whereas large files tend to be more sequential. And the reason IOPS matters is if you're reading a bunch of, let's say you're reading thousands and thousands of teeny tiny files. The limiting factor for how many files you can read per second is probably not how many megabytes per second can your NAS read and write. When the files are really teeny, the bottleneck for how fast you can read those files tends to be more in operations per second, because every file you read will be at least one operation, if not more. So if you're trying to read thousands and thousands of files, how fast you can read those files, the limit to how fast you can do that becomes more a matter of how many operations per second can your NAS handle, and that starts to matter more than megabytes per second when the files are very small. And just to throw this out there now, for virtualization, in most cases, IOPS matters more than throughput, though there are some exceptions. Transcoding. If you want to use the NAS as a media server, transcoding is an excellent feature. Transcoding allows you to convert a video stream from one format to another. Let's say whatever you're playing the video stream on can't handle the format you have. You can change the format to make it compatible. Also, let's say your Plex server is at home and you're at some hotel somewhere using some hotel Wi-Fi that's not that fast. The Wi-Fi may not be fast enough for, let's say, your 4K media. Transcoding can also lower the resolution. It can lower the bit rate so that you can play smoothly even when your internet's not that fast. So transcoding is an excellent feature, but transcoding takes computing power. Transcoding can be done by a GPU or by integrated graphics, and transcoding can be done by a CPU. However, graphics or GPU can do transcoding much more efficiently than a CPU. And that's why some of our NAS are much better at transcoding than others. And that's because some of our NAS have integrated graphics, whereas other NAS don't have integrated graphics. And when you run Plex on a QNAP, Plex can hardware transcode using the integrated graphics on an Intel CPU. So if you want a Plex server, you probably want an Intel CPU with good integrated graphics. And that's why, for example, the TS1685, though it's a great unit, does not transcode as well as the TVS472XT. That's because the 472XT has good integrated graphics, whereas the 1685 has a Xeon with no integrated graphics. Xeons are great, but for a Plex server, you're better off with graphics. So let's talk about RAID. RAID is when you take multiple drives and combine them together. First of all, to get more capacity. I think that should be obvious. But the other thing is different RAID configurations will offer various amounts of redundancy. So with different RAID groups, typically you could lose maybe 1 or 2 drives without losing any data because they have redundancy. So RAID is there for capacity, but also RAID is there for safety, for redundancy. Also, RAID typically offers more performance. For example, for most RAID configurations, when you have more drives, you typically get more throughput. Now, you may not always gain as much in IOPS with more drives, but you typically gain more throughput as you get more drives. And this is important in configuration. I'll get more into that later. But for now, I just want to say that RAID can be optimized. Some RAIDs optimize for maximum capacity. Some RAID configurations optimize for maximum redundancy, data safety. Some RAIDs are optimized for performance, especially like RAID 10 is excellent for IOPS. So how you configure RAID, the best RAID configuration for your use case depends on what kind of performance you need, what's most important. Is it performance? Is it safety? Is it capacity? Is it throughput? Is it IOPS? All these factors affect what is the best RAID configuration for your use case. So let's talk about HDDs versus SSDs, because our QNAPs can take both. They can take all of the QNAPs we currently sell could take either HDDs or SSDs in the drive base. So they both store your data, but they're different. HDDs, for example, are a lot more cost effective. It's much lower cost per terabyte with HDDs, but SSDs are higher performance. But how much better their performance is in SSDs greatly depends on the use case. For example, SSDs are orders of magnitude better at random reads and random writes. But like a SATA SSD might be only, say, twice as fast at sequential reads and sequential writes. So whether or not the SSDs are worth the extra money might depend on, is it more for random reads or more for sequential reads? As I mentioned before, when it's a bunch of teeny tiny files, it tends to be more random, where IOPS matters more. But if they're medium to large files, it tends to be more sequential. And for medium to large files, HDDs are typically just fine. So as I mentioned, yeah, SSDs are much better for IOPS, much better random performance, orders of magnitude better for random, but to a lesser degree, they're faster sequentially. But I want to point something out here that I mentioned here, that with more drives, you typically get more throughput. So if you have, let's say, just 2 SSDs, like RAID 1 or something, but you have, say, 12 HDDs, like a lot of HDDs, you might find that your HDD RAID group has more throughput than your SSD RAID group. Because you think about it, if SSDs have maybe twice the sequential throughput of HDDs, maybe twice the throughput, but there's only 2 of them, the throughput of like 12 or more HDDs might be more than the throughput of your SSD RAID group. And this becomes really important when you're thinking about cache or queue tier, because if you try to use cache or queue tier to accelerate throughput, but your SSD RAID group has less throughput than your HDD RAID group, cache could actually slow you down rather than speed you up. And I've had customers this has happened to, and this problem can be avoided as long as you configure your cache correctly. So let's talk about our caching feature versus our QTier feature. Both these features are designed to allow you to have large capacity, cost-effective HDD storage, but also use SSDs to accelerate that storage. And they both have the same purpose, but they work a little bit differently. So first, let's talk about a QTier. Here's a picture of how QTier works. You can have up to 3 tiers: SSD tier, SAS tier, SATA tier. And so your hot data, or your data that is accessed most frequently on average, will be moved to your SSDs. Your warm data, or your data that's used semi-frequently, will be moved to your SAS drives, assuming you have SAS drives. If you don't have SAS drives, there's only 2 tiers. Then your cold data, or data that's used least often, is on your SATA drives. And in this way, if the data that you use most often is in your SSDs, then the hope is that most of the time you access a file, most of the time you're accessing it from the SSDs and enjoying that SSD speed. But you can still have very large capacity HDD storage. So this is a very cost-effective way of having HDD storage, but accelerating that storage with SSDs. And caching works very similarly with cache. When you open up a file, it just immediately copies it to the SSDs so that immediately you can work off that from SSDs. So to get more into the differences, cache has the advantage of just that immediate performance boost, because immediately when you open up a file, it immediately moves that file to the SSDs. QTier will move files to SSDs on a schedule. Cache has the advantage of that it's more customizable. You can set cache to only accelerate random reads and random writes, or you can set cache to also accelerate sequential reads and sequential writes. Remember I mentioned here, if the throughput of your SSD RAID group is less than the throughput of your HDD RAID group, you don't want to try to accelerate sequentially. So in that case, you want to set your cache to random only. And QTier cannot be customized that way. So basically with QTier, if the throughput of your SSD RAID is less than your HDD RAID, just don't use QTier. So let's go more into the differences here. Here's a table that kind of compares QTier to cache. So both these are designed to have a low-cost way of having lots of storage, but still benefit from SSD speed. But for some of the differences is that QTier takes less resources. So this is one big advantage of QTier. For example, SSD cache requires RAM. And so the more RAM you have, the more cache you can have. Like if you want to have the maximum 4 terabytes of cache, you need to have at least 16 gigabytes of RAM, because cache just takes more resources than QTier. With QTier, you can have a small amount of RAM, but still have a very large SSD tier. And there's no significant limit on the size of your SSD tier. So even with a small amount of RAM, you could have significantly more than 4 terabytes of QTier. But the cache has something that I think in a lot of cases is an advantage, is that the data migration method is automatic. The moment you open up a file, it just automatically immediately moved to the SSDs or copied to the SSDs. QTier does this on a schedule. So in a lot of cases for video editing, I tend to recommend cache instead of QTier, because it just immediately will copy a file you open to the cache. But it does depend a bit on the use case, which is better. But usually I recommend cache for video editing, but there are some exceptions. And I don't want to go too much into detail on this, but just as a general summary, QTier takes less resources. QTier lets you have a larger SSD tier, but cache will immediately take a file you open, immediately put it on the cache. And so that's the advantage of cache. And cache is more customizable, so that if you have an SSD RAID group with less throughput than your HDD RAID group, you can set the cache to random only, and then it still helps. So let's go over some various use cases. So we're going to go over file server, Plex server, a NAS for video editing, virtualization, surveillance, and more. So first of all, you want to know kind of what performance factors, kind of what affects the performance of each factor. So kind of what affects performance in what category. So for example, RAID configuration will affect your capacity, your storage capacity. The RAID configuration you choose will affect your throughput. It will affect your IOPS and your data safety. So what RAID you choose will determine how you perform in these categories. Your CPU power will affect your throughput. It will affect your IOPS. It will affect your computing power. Integrated graphics will affect your transcoding ability if you want, say, a Plex media server, and it will affect your ability to have HDMI playback. Your network connectivity will affect throughput and IOPS, and your drive types like SSD, HDD, NVMe SATA, this will affect your throughput, your IOPS, and your capacity. And number of bays can affect both capacity and throughput. Remember I mentioned when you have more drives, you typically get more throughput. So let's go for a brief comparison of different RAID configurations, because when you choose your RAID, you want to optimize. You can optimize for safety, you can optimize for capacity, you can optimize for throughput, you can optimize for IOPS. You have a lot of choices here. So let's kind of go over some of your most common options. So RAID 5 gives you a lot of capacity. It only costs you 1 drive worth of storage. So if you had, say, 8 drives, you would have 7 drives worth of usable storage because it only costs you 1 drive worth of storage. And RAID 5 will allow you to lose any 1 drive and still keep your data. RAID 6 is a little bit safer. RAID 6 allows you to lose any 2 drives and still keep your data. But RAID 6 costs you 2 drives worth of storage. Now, as far as for performance goes, RAID 5 performs slightly better than RAID 6, but they're actually pretty close. Now, RAID 10, on the other hand, RAID 10 is a lot more costly. RAID 10 will cost you half of your drives worth of storage. So if you had, say, 10 drives, you only have 5 drives worth of usable storage. It's very costly that way, but the advantage of RAID 10 is performance. RAID 10 offers very good read performance especially, but also still quite good write. But RAID 10 especially has excellent IOPS. And that's what RAID 10 I'd say is most optimized for. You get excellent IOPS with RAID 10, but you lose half of your storage. And then there's RAID 50 and 60. These both have excellent throughput. Not as good IOPS as RAID 10, but excellent throughput. And they're generally less costly than RAID 10. You get more capacity than RAID 10. Between RAID 50 and RAID 60 is safer than RAID 50, but RAID 60 is a little more costly than RAID 50. RAID 60 will cost you about twice as much for your redundancy. So like RAID 60 and 50 can be excellent for video editing because they give excellent throughput. RAID 10 could be excellent for virtualization because it gives excellent IOPS. Most file servers would choose RAID 5 or 6 for maximum capacity. So this is what you can think about when you optimize your RAID configuration. So let's talk about a file server. What's important for a file server? Well, typically capacity is important. You want to have a lot of storage. And connection type can be important. Do you just need a single gigabit Ethernet? Do you want 10 gigabit Ethernet? So if throughput is important, then the connection type matters. And so for file server, CPU power does affect throughput and IOPS. So if you want a high performance file server, then CPU power can matter. If you want a high performance file server, then 10 gigabit might matter. If you just need a low performance file server, then this may not be very important. So to configure for the file server, typically choose RAID 5 or RAID 6. This gives you excellent storage capacity. RAID 6 especially gives you good safety, and it's good performance for medium to large files. And if you have many small files, then you might choose to use some SSD cache, because SSDs are orders of magnitude better, as I mentioned, for random reads and random writes. So for for lots of teeny tiny files, SSD cache helps a lot. And if the files are mostly large, then cache is probably not needed. So some good options for file servers. If you don't need particularly high performance, then even a NAS with an ARM CPU is fine, or like a 51 series Intel CPU, 53 series is just great. But if you want higher performance, then for just a few $100s more, the 73 series offers, I'd say, much better performance at not even that much more money. And then even more performance than 73 series is the 72 series. And we have the 1685, and the 83 series and 77 series are very high performance file servers. So depending on what's needed, ARM or Celeron when you don't need particularly high performance, but we also have some very high performance options starting at 73 series and up. So let's talk about Plex server. What's important? Well, capacity is probably important. You might have a lot of video files, movies, whatever. And transcoding ability is important. And that means CPU power matters and integrated graphics matters. So even though I had mentioned that a GPU can typically transcode, for Plex on our NAS, it's not always easy to get Plex on our NAS to use a GPU. So for the most part, you want a NAS that has a CPU, an Intel CPU with integrated graphics, because Plex will hardware transcode using the integrated graphics on an Intel CPU. And so that's what you want to prioritize with Plex is transcoding ability. And that means probably a decent CPU and good integrated graphics on an Intel CPU. So to configure for Plex, RAID 5 or RAID 6 for good capacity, and RAID 6 offers great safety. You typically don't need cache, and that's because with Plex, you don't really typically need to think about accelerating your throughput. Usually the bottleneck, the limiting factor is how fast can you transcode. So you don't necessarily need to think about lots of SSDs for more throughput. The limiting factor is really your transcoding ability in most cases. So some excellent NAS for Plex are the 72 series are the best for Plex that we offer. Like right now, if you have a 72 series with i3 or better, it will transcode very, very well. And out of all the NAS that we offer, none of our NAS transcode better than the 72 series when it comes to Plex. But if you're on a tight budget, the 53B series and the 51X series transcode very well as well, especially for that price range. They'll transcode multiple streams of 1080p at the same time, and they can do at least most 4K streams as well. Though if there's some really high bit rate, there could be some cases where there could be some struggle, but they can do most 4K. They're excellent at 1080p, and if you can afford the 72 series or 72 series is amazing at transcoding. So let's talk about a NAS for video editing. What's important for video editing? Well, capacity, you might have a lot of raw footage. You might just be regularly just taking more and more footage, and that can add up fast. So some editors just keep needing more and more capacity. And then throughput really matters. Typically, a video editor wants to be able to video edit directly off of the NAS. And so, you don't want to have to wait to copy your data from the NAS onto your computer. It's a lot more convenient if you can edit directly off the NAS. And very often in a studio, you want to be able to have multiple video editors editing off the same NAS at the same time, because that's what the NAS is for. It's for excellent collaboration, right? A network drive in a NAS can be mapped onto many computers at the same time, so that you can all video edit off the same raw footage at the same time. That's what a NAS is for. But if you have multiple editors editing off the same NAS at the same time, each editor needs throughput. And when you have multiple editors at once, a lot of throughput can be required. So when you have a NAS for video editing, you're typically taking a NAS that's optimized for capacity and for throughput. And since you want high throughput, connection type matters, right? You probably want a 10 gigabit connection or a 25 gigabit connection, 40 gigabit or Thunderbolt connection. You typically don't want to edit through just, single gigabit, and definitely not Wi-Fi. And when you start to have more editors at once, IOPS starts to matter more, right? When multiple editors are editing off the NAS simultaneously, they might be getting different footage at the same time, and so IOPS becomes more important. So when you configure for video editing, you're mostly configuring for maximum throughput. So when you have maybe one or two simultaneous 4K editors at once, multiple HDDs is probably enough. As I mentioned with RAID, when you add more drives, you get more throughput. So if you have at least 4 drives in a RAID, and then as you add more, you get even more throughput, that's typically fine for 1 to 2, 4K raw editors. But as you start to get more editors and need more throughput, and also you also start to need more IOPS with more editors, some NVMe cache can help. And here I want to mention that NVMe SSDs are a lot faster than SATA SSDs. These days, NVMe SSDs can be about 4 to 6 times faster than SATA SSDs. So this is a big difference. So if you want a cache for video editing, I highly recommend NVMe. Most of our mid to high-end NAS have multiple PCIe slots to allow you to put in a QM2 card that holds NVMe drives. And this is something that sets us apart from some of our competitors, is that we have higher performance NVMe cards than some of our competitors out there. And our NAS tend to have more PCIe slots than some of our main competitors, so that you can have more NVMe storage, high performance NVMe storage. Our QM2 4P384 is our highest performance, best QM2 card. It can hold 4 NVMe drives. It has Gen 3 PCIe, and it has 8 lanes of Gen 3 PCIe. So this can offer some very fast NVMe cache. And just another option besides cache is some editors do choose a NAS with all SSD storage. That's the other option. That option is more costly, but it's a very good high performance option. So for video editing, if you want a Thunderbolt NAS, we have our 72XT series and our 82T series. So our 72XT series has excellent throughput, but it has only 2 Thunderbolt ports. And then we have like our TVS 1282T3, which has 4 Thunderbolt ports. So I would say our 72 series, its throughput is actually just as good as our 1282T3. So if you only need 2 Thunderbolt ports, I'd say get the 72 series because it's very cost effective and very high throughput. But if you need 4 Thunderbolt ports, then we have our TVS 1282T3 with 4 Thunderbolt ports. Both these are excellent performance. If you don't want Thunderbolt and just want 10 gigabit, then you can start at our 73 series. Our 73 series, when you add a 10G card to it, could be good for maybe 1 or 2 editors at once. And then the 72 series has better performance than the 72. The 72 series has better performance than the 73 series. And the 83 series has even better performance. And also 77 series can have very good performance as well. Both these are excellent performance NAS. And then we also have our TS 1685 and 1677X, both have very good performance. So Thunderbolt or 10 gigabit, both excellent options. And really top of the line would be like 83 or 77 series. So let's talk about a NAS for virtualization. And let's talk first about Virtualization Station. When we talk about virtualization, there's kind of 2 things we could be talking about. We can talk about using our hypervisor, Virtualization Station. And that means our NAS is doing everything. In Virtualization Station, our NAS isn't just storage, but our NAS is doing the computation, doing the computing for the VM. And that means you will assign a certain amount of CPU cores for the VM. You will take a certain amount of RAM on the QNAP and assign it to the VM. What that means is that when you have multiple VMs, you're using a lot of CPU cores from the QNAP. You're reserving a lot of QNAP RAM for the VM. So you need a huge amount of CPU power and a huge amount of RAM when you have multiple VMs running on the QNAP NAS when you use Virtualization Station. So what's extremely important is a lot of CPU power and a lot of RAM. But now what is also sometimes important are IOPS, and what's sometimes important, what may or may not be important, is a 10 gigabit connection to your VM. And the ability to take a GPU may or may not be important. We have GPU pass-through, so you can give a GPU to a VM. And depending on what that VM needs to do, that may or may not matter. Now you can also use a QNAP as storage for a VM. And that means that it's just storage. So the QNAP is not doing the computational power for the VM. You're not taking QNAP RAM and assigning it just to that VM. You're not taking cores on the QNAP and assigning it just to that VM. So you don't need as much CPU power as with Virtualization Station, but CPU still matters. And the reason why CPU still matters is because CPU will still affect your IOPS. When you have a more powerful CPU, you will have more IOPS and you will have more throughput. So when you are configuring for virtualization storage, you're configuring for maximum IOPS. That's typically the number. Capacity can be important, and IOPS. And when it comes to performance, you're configuring for maximum IOPS in most cases. And connection type also often matters. You might want 10 gigabit, 25 gigabit. Fiber channel offers a special low latency connection. We also have ICER, which allows a special low latency connection for better IOPS. And so IOPS is kind of the number one performance factor you're typically thinking of when you're talking about virtualization storage. So when you can configure for virtualization, you're configuring for IOPS, as I mentioned. So you might want to choose to store the VMs on SSDs because SSDs have orders of magnitude better IOPS than HDDs. But if you're looking to save some money, you could have HDD storage, but maybe you might choose to use some, say, SSD read cache for example. And if you're using, say, VMware or Hyper-V, ICER is an excellent protocol that allows for a lower latency connection from the QNAP to, say, like a VMware server, and that means more IOPS. So if you want a NAS for Virtualization Station, you basically you want a NAS with a whole lot of CPU power. So our 77 series can go up to an 8-core, 16-thread Ryzen, so that has pretty good CPU power. And our TDS 16489U can go up to 2 10-core Xeons. So you can have up to 20 cores total on a TDS. So our best, hands down, is the TDS, but it is more money. If you're on a budget, you could consider 77 series. These are both good options for Virtualization Station. Make sure you get a good CPU and make sure you have lots of RAM. For Virtualization Storage, you want NAS that have excellent IOPS. So our 77 series, our 83 series have excellent IOPS, and our 72 series still have quite good IOPS, and they're a little bit lower cost. And those are for the rack mounts. For the tower, you typically want, for either of these, you typically want SMB high-end and above. So if you go to tower, you can maybe start at the 73 series because it is a big jump up from just 53B or something like our Celeron or ARM. The IOPS is really a lot less. So I'd say start at the 73 series, but up from there, the 72 series is better performance. And even better would be like 77 series, better performance, and like a TS1685 has very good performance. So in the tower, these are where you can go basically SMB and above, and I wouldn't recommend less than the 73 series. And kind of top of the line would be like 83 series. So let's briefly talk about video surveillance. First of all, number one thing for video surveillance, I'd say don't use cache. And that's simply because typically the way cache works is maybe when you write to the NAS, if you have, say, write cache or read-write cache, you write first to the SSDs, and then when there's some downtime, the SSDs will flush that data to the HDDs to make more space for new data. But with surveillance, you are constantly writing to the NAS. You constantly record to the NAS. There is no downtime. So the cache will very quickly fill up, and then there's really no downtime. There's no good time to flush that cache. So then pretty soon you can't write to the cache faster than you can flush the cache to the HDDs, and then the cache will probably even slow you down a little bit. You get no benefit, and the cache might even make you a little bit slower. So just don't use cache for Surveillance Station. So if you want to use a NAS as a file server or for other things, you could use cache for that, but just make sure not to apply the cache to the volume where you're recording footage. Besides that, typically for surveillance, most people would use multiple LAN ports. The 10 gigabit tends not to help as much as you might think. I found most people will just use multiple gigabit LAN ports. So let's say there's maybe 4 gigabit LAN ports in your NAS. You probably want to balance your cameras. So if you have, say, 20 cameras, maybe have 5 cameras record through each of the 4 LAN ports. Typically, you configure RAID 5 or RAID 6 for maximum storage capacity, because if you want to have a lot of cameras, hold the footage for a long time, you're typically configuring for capacity. And it's good to start with 86 CPUs, so Intel AMD 86. So I don't typically recommend ARM. We do have ARM that can do surveillance, but if you start with 86, I think it performs better. And our new QVR Pro, it requires at least 4 gigs of RAM. But if you want to have a lot of cameras, it works better with 8. And also, if you want a unit that has HDMI playback, I highly recommend. I think you should have at least 8 for HDMI playback. So I think 8 is a good, for best performance, I recommend 8. So that's kind of it. Those are kind of the main scenarios I wanted to talk about, but I'll be here to answer some questions. So if you feel like your use case was not covered, feel free to ask questions here, or feel free to email me later. I'm very happy to hop on the call. You can call us anytime. We're here to help you get the best performance out of our products. Thank you.